Hi everyone. So the statement by René Descartes is, "I think, therefore I am." But this statement might be changed over the next 50 years. So I would highly appreciate it and join this podcast, and I would be honored to welcome Dr. Nate Tenhundfeld in this podcast. So. Hi, Dr. Nate Tenhundfeld.
Hey, yeah, I'm impressed with how you got the last name. That's good. It's not an easy one.
Yeah, it's difficult, but yeah.
It's good to be here. Thanks for having me.
So we're gonna talk about what is the human factors change over the course of the advancement in technology in artificial intelligence, so let me give the brief introduction of yours to our audience.
Yeah.
So. Dr. Tenhundfeld is he's the president of the Tennessee Valley chapter of the Human Factor and Ergonomics Society, and also PI of ATTAC Lab at UH. Also, he has received many research grants as a PI and a co-PI to work on user experience and human-machine teaming projects. On top of that, he has been invited as a guest speaker to numerous conferences and meetings, including the annual Lockheed Martin Autonomy Executive Steering Committee meeting. He is the author of more than 25 papers and was awarded the 2018 Raja Parshuram Award for Scientific Impact by the International Neuroergonomics Society. So, again, welcome, Dr. Nate.
Thank you. Thank you.
Yeah, so let's start with what is your academic journey or education journey over the last years?
Yeah, absolutely. So I started my undergrad actually down the road at Auburn University as just a psychology student.
Yeah.
After a year there, I loved it, but I wanted to transfer back closer to home, so I grew up in Virginia. And so I went to the University of Virginia for my undergrad. At the time, I don't think I knew what I wanted to do. I even wound up minoring in astronomy. I mean, it has nothing to do with psychology, but it was not until I think the last semester of my senior year that I decided I wanted to go to grad school, which was not great because I hadn't done any of the GRE or anything like that. So I wound up taking a year off, but then kind of found a niche that I was really interested in for research. And so I applied for graduate school at Colorado State University, and there was focusing mostly on human vision. And so looking at the visual system as a function of potential top-down or bottom-up. I can go into that if you want me to, but processes. After that, I went to the Air Force Academy for a 2-year postdoc, and that's where my research kind of really pivoted to what I'm doing now. And so that was more human-machine teaming. I was there until 2019, working out of what we call it the Warfighter Effectiveness Research Center at the Air Force Academy, and then had the opportunity to come here to UAH in 2019. So,
awesome.
Yeah.
Oh, so you have a whole expanded journey of figuring out your passion and indulging into your passion, and here you are.
Yeah, man, and I tell everybody that asks, I'm the luckiest man alive. I stumbled into this career, but I can't imagine doing anything else. I love what I do. I love the research I get to engage in, and I had no idea, even months away from graduation undergrad, that I was going to be doing this. So it's worked out.
That's an inspiring journey, I would say.
Well, thank you. Some would call it inspiring, some would call it poorly thought through, but it worked out. Yeah.
Well, so I would say, like, when you find out your passion, you sit on the hypersonic plane and you just ran into, because now you have thrust to grow in that particular field. So, after that, your growth will be exponential when you figure out what you want to do for your enjoyment. So work seems like fun, basically.
Absolutely.
At that point of time.
Yeah. I mean, I work all the time, but it doesn't feel like work.
Yes,
I
exactly.
still love doing what I'm doing.
Yeah, like basically, sometimes when I feel that I am doing what I love, I'm in that zone. I think psychology people call it zone. When in that zone, when you detach yourself at times, basically.
Yeah. When you can get in that flow and the hours just melt away.
Yes,
it's a good position to be in.
It's good. Yeah. So let's talk about a little bit technical stuff. So first of all, my first question is, what is cognitive psychology?
Yeah. So when you look at the context from which cognitive psychology arose, I think it helps to contextualize what cognitive psychology actually is, right? And so traditionally, psychology was focusing on what we just call behaviorism, right? And so this is it's still a line of research in psychology, but it's not necessarily of the same prominence that it used to be, right? So behaviorism used to say, well, it still says, but would focus on here are the inputs to the human, the information, and here's the output. So it's the human behavior.
Right?
I see. So we care about inputs, we care about outputs. And they didn't really care what happened in the middle, right? So they don't care about what's going on necessarily in the brain. Now, this is an oversimplification, obviously. But it's the inputs, something happens in the middle, and you get these outputs.
Yeah.
Cognitive psychology said, we're going to kind of hyper-focus on what's happening there in the middle, right?
Okay,
so,
interesting.
Yeah, so as we start thinking about effects of learning and memory, right? We start thinking about effects of trust, which is my particular interest. That pertains to cognitive psychology. And so what I usually tell people is, when you think of psychology, you think of two things typically. One, you think of therapy, and the other you think of, why do people think what they think, right? And so cognitive psychology is that latter bit, right? And so you even see this kind of manifest in other fields and other domains. So behavioral economics is kind of an inherently cognitive field, even though it has behavior in the name there, focusing on kind of the irrationalities of the human decision-making process that leads us to make kind of non-optimal decisions. And so this is a very roundabout way of saying that cognitive psychology is really focusing on that middle part of the transformation of the inputs to that resultant output.
I see. So basically it's a bridge between input and output. So basically it's a kind of black box, and you're figuring out what is going on in that black box.
Exactly. I mean, so if you just think about it in machine learning, right? You have the inputs, you have the outputs.
Yeah.
Cognitive psychology are all the hidden layers.
All right. So you're exploring neural networks, basically.
Yeah, there you go. Exactly. Exactly.
All right. Okay. So what's specific area? So you are focusing on exploring what's going on in our brain, or so what? Like the cognitive technology deal with the behavior or brain structure, or both maybe?
A little bit of both. So human factors, that's what I predominantly focus on. Is kind of unique in the sense that whereas a lot of academic disciplines, especially in psychology, are more focused on the basic side, so the theoretical development, human factors does that, but we also focus a lot on the applied. And so there's a lot of integration into the real world. And so there are still absolutely theoretical considerations to be made. We need to understand the functioning of the brain to actually be able to model what human behavior is going to be. But there's also a big component of the prediction of the behavior in that instance, right? So as we start making recommendations to the community of self-driving car manufacturers, there needs to be an understanding of, okay, not just the theoretical, but what are the actual behavioral implications of your design choice in the actual resultant interaction between the human and the system.
I see. Okay. And so also it affect the day-to-day life of the people, how they, so like in advancement in the cognitive psychology, what's a particular implementation for the normal human being in the day-to-day life? Because like this is very highly, so input, output, we all people get inputs and something going on in the brain. The study is the cognitive psychology, but what is the application? How we can experience more, for example, self-driving car, right? So when you have autonomous car in your hand, you are just sitting there, right? But what is I would say, how you can improve that experience? That also involved in cognitive psychology?
Oh, absolutely, yeah. So we talk about, and I'm going to just go back to specifically human factors, but I think this pertains to any sort of applied elements of cognitive psychology. Essentially, the three goals of what we do in human factors from an applied perspective is increase safety, increase performance, and increase satisfaction.
Oh, okay.
Right? And so that can be everything from what are the design elements that affect the actual safe interactions with the system, but it can also be, I know we were talking about before, I have a whole bunch of Apple products, right? Apple has gotten me to buy into their ecosystem. Right? And that is an inherently cognitive element to it. Because what they're trying to do is create these associations, but also, it essentially builds off of this kind of animalistic tendency we have of in-group versus out-group, right?
Oh, yeah.
Apple versus PC, right?
Yes.
Auburn versus Alabama, etc.
Oh, okay. So now, what are the major projects? So we talk about what is cognitive psychology, right? So let's talk about what are the major projects you have been involved currently, or your past projects, or what your current projects are.
Yeah, so when I was at the Air Force Academy, I was very fortunate. I came into a lab with a lot of, pardon the phrase, cool toys, right? I mean, research toys, but and one of them was an actual Tesla, right? And so we had the opportunity to be among the first labs to actually publish data with these real, quote unquote, self-driving cars.
Yes.
In somewhat of a realistic world environment, right? There's still confines we have to take to make sure that we're protecting the human subject. But we're looking at several different things, right? So one of the projects we looked at with the Tesla was the familiarity with the system and how that kind of interacts with your trust of the system. So I think a great example of this is when Tesla brought us our car, he essentially handed over the keys and said, have fun, right? And so, and so there was not this necessarily explanation of the different features so much, or, the bounds in which the system would, perform a certain task. But he just handed it over. And so I remember distinctly, one of my collaborators, Dr. Vic Finnemore, at West Virginia now, was, I think, one of the first ones to actually drive it. We went out to go use its auto parking feature. He found a spot, and I think it was 4 straight trials. The car started backing in, and he just hit the brakes. He didn't trust it to actually continue out.
Oh, really?
Yeah, and so this kind of raises the question of, okay, does having any degree of familiarity of how the system's going to work dictate your willingness to rely on it, right? And what we find, is right at the beginning, when people don't know how the system's going to do it, right? When you pull into a parking spot, most of the time you're pulling in nose first, right?
Yeah.
But what Tesla does is it pulls past and then it starts backing in, but it backs in with at least a 3-point turn. And so it'll come back towards the car, or at least this is how it used to be. I don't know if it still is, but it would come towards the car, it would stop, it would straighten out, and then it would pull back in, right? And so there's this window wherein if you don't know what the system's going to do, you don't know at what point it's going to stop. Right, because it keeps getting back closer and closer and closer to that other car.
So you're kind of building a fear in your brain. Oh, I'm gonna hit this car.
Yeah, exactly.
Yeah, so that's why you instinctively put your pedal on the brake.
Yeah. I mean, even if you don't, like in this case, there's no real threat of physical injury.
Yeah.
But there's still issues associated with. Wrecking an $80,000 car is not great. And so, what we found is those who were given some degree of information or saw it work the first time tended not to intervene. But those who didn't have that information, over half did intervene on that first one, right? And so it's one thing in a parking environment to have that intervention. It's another thing to potentially at highway speeds have that intervention because you don't know what it's going to do.
Yeah.
And we see this all the time in all different domains of people overreacting to whatever stimulus is.
Yeah.
Right. So one example would be pilot-induced oscillations. Right. And so you start doing this. And so you get that even in vehicles sometimes. So we had a series of projects with the Tesla. That was obviously my postdoc. I came here. We've still continued some of those. So I'm still collaborating with some folks at the Air Force Academy. But since I've gotten here to UAH, I've kind of moved away from Tesla specific or self-driving car specific, and now focusing on kind of some of the broader issues inherent with automated technologies. So a couple of my graduate students and I just published an article looking at people's mental models of virtual personal assistants. And so we'll see if I can say it without it actually setting off, but is your perception of Siri do you think of it as a single entity that everybody interacts with the same, or do you think of it as individual nodes, right? And so what is your thought?
I thought, for me, when I interact with Siri, it has, so basically, if I took, critical manner, Siri has a lot of information about myself, basically. Like see it. See, like I consider as like my assistant, right? So I instinctively say the C, like though it's a kind of computer model, but yeah, she knows a lot of my stuff, like what I like, what I dislike, which type of music I like. Because initially I got information, hey Shiri, play this music, call this person, right? So I think for me it seems like my personal assistant. Yeah, so I considered that like particular algorithm as my own. But yeah, like other my friend, they have their own series. Like they have their own personal assistant which they knows that like and dislikes for themselves. Yeah. So I consider them as like individual entity, but I know like on the back of end it's just a computer algorithm which knows all the because it's kind of integrated all the people's information. So yeah, but on the top level, I consider that as my individual thing.
Yeah, well, I mean, you're kind of an interesting example because you have domain expertise in essentially programming, right?
Yeah.
But I think it's really interesting to hear you articulate that difference because to some degree there is kind of this expectation of it knows something about me, but I don't know where like one Siri ends and the other begins.
Yes.
Right? So if my Siri, my phone screwed up, we don't really know whether that would, and you observe that, whether that would be reason enough for you to stop trusting your Siri, right?
Right.
And so, you know, this question is, although it appears fundamental, it's kind of critically important as we start thinking about these systems moving forward. Because all of these companies are developing, even if not a virtual personal assistant, a kind of ecosystem in which they're all interacting, right? And so does my interaction or my observed interaction with somebody else interacting, is that going to influence my expectations of my own system? And what are the bounds of that, right? So if I have a Siri in my phone, is that going to affect my trust of Siri if Apple puts Siri in a self-driving car, right? And am I extrapolating the Siri in the self-driving car to the totality of the self-driving car?
I see.
Yeah, and so we have this really interesting case where the field up to this point hasn't been able to answer the very simple question, right, of is my Siri the same as your Siri, right? And what doesn't matter in these cases, and this is kind of one of the nuances of psychology, what doesn't really matter is the objective truth, right? It doesn't matter necessarily what is objectively true about where one Siri ends and one begins. What matters is what people expect or believe.
Oh, yes. So it's based on like, like in the technical term it's whole different game, but in the brain term, like what we experience, we thought, we believe, it's whole different game to take away.
Yeah, exactly.
Okay.
And so, you know, that has been part of our exploration of actually trying to just define what constitutes a system in the minds of users.
I see.
Yeah, and then, go ahead, I'm sorry.
Also I want to add, like when we extend the Siri from mobile to any other device, for example, self-driving car or maybe in the future plane, can we trust them?
Yeah.
It's a bigger question to, you know, because like it's not equal, I trust my mobile phone Siri equal to I trust on my self-driving Siri, because in self-driving I'm risking myself. In mobile I'm not risking myself.
Yeah. Well, and I think that's another really interesting kind of open question in the field of typically how we've defined trust doesn't make room for necessarily a risk element, right? And so typically what we are considering when we think about trust is your expectations that a given system is going to help you accomplish a given task, right? And so John Lee kind of has that definition, and it's usually in a task characterized by vulnerability or uncertainty. The problem is that we do have these observed effects where people's trust varies as a function of the risk. Right? And this kind of gets back to that initial question of cognitive psychology versus behavioral psychology of, you know, your trust may not change, but your trusting behaviors may change, right? So you may be less willing to let Tesla get to that edge at, you know, 75 miles an hour than you're willing to let it get in just a parking lot or something like that.
Oh, yes.
But I mean, it is a really interesting question, right? Because so much of the consideration of these systems does boil down to the trust with the systems, right?
Yeah.
And the battle we constantly fight, kind of on the human factor side, is with engineers who say, we'll just train them, right? But training is not always the answer, right? It's got to be an element of comfortable interaction. And I think the best way, and I'll get off my pedestal here in just a second, but I think the best way to kind of illustrate this is if you're riding in the car with somebody else, right? So if I'm driving and you're sitting in my passenger seat, and I do something that makes you uneasy, you communicate something to me, right?
Yeah.
It doesn't have to be verbal, right? I can see you kind of bracing in your seat, or I can do the little, phantom stomping on the brake pedal that doesn't exist. But there is that degree of communication. And to date, there has not been any attempt of the vehicle to understand the human in that context, right?
Yes.
And so what we're reliant on is the human to either express distrust through an intervention, so hitting the brake, disengaging, auto driving, stuff like that.
Yeah.
Or just kind of exist in their distrust. Right? There's not this kind of reassurance loop that would be, you, Chris, saying, Nate, you almost missed, or you almost hit that pedestrian there.
Yeah.
I said, no, I didn't. I saw, they were turning there. And so I can reassure you, or I can say, yeah, I screwed up.
Yeah. So this factor is not exist till now in the self-driving car.
Yeah. I mean, there's nothing.
What if, what if we develop the system which analyze the human behavior, right? Like the person who is sitting in the driving seat, Tesla, steering is there, but it's autonomous, it's driving by itself. Rather than inputting the user behavior, what if I observe constantly the driver, and based on his expression, my computer system, so of course one area, my self-driving car working its system and analyzing all the view and driving basically. The other system which monitor the driver and take the information and it inform that this is what I'm doing. You see, this is what I'm doing and I think it's right.
Yeah.
Tell this information to user.
Yeah.
So that's why it's kind of building a trust. So when I drive, you sit beside me, I'm telling, hey, I'm going to 70 mile or 80 mile per hour, but it's okay, it's highway. So I can go there.
Yeah.
Yeah,
well, and I think what you're hitting on is a really important line of study in the field on this whole idea of transparency, right? And so you see this sometimes talked about explainable AI, right?
Yes.
So for some of the concerns we have moving forward, but just inherent, transparent designs that communicate the system state to the user, right?
Yeah.
So the user can know, okay, yes, it in fact does see this car up here, and therefore I'm okay, right?
Okay.
But one of the issues you see, and I have a bunch of gripes with Elon. I think he's a genius, but I also think he makes really irresponsible decisions at times. And one of the biggest concerns is that he has historically kind of poo-pooed the idea of monitoring the individual, right? Now, he's not monitoring it for the context of trust. He's monitoring it, or the conversation usually revolves around paying attention.
Yeah.
But there is still this element of there needs to be better communication, right? Because you see all these cases wherein the vehicle will slam into the back of a fire truck, right? And they're obvious, I mean, this is your domain, so correct me if I'm wrong here, but my understanding is there are issues inherent with computer vision in the processing of red, right?
Yeah.
And so the human visual system, we also struggle with this, right? We've known for decades that fire trucks should actually be lime green, right?
Yeah.
Or at least just not red, because we have two different types of systems, a day system and a night system for our visual system.
Yes.
And the night is particularly bad at picking up red, but the day is not all that great.
Not all that,
either, at least when compared to lime green or something like that. But when the vehicle when a Tesla, and I'm picking on Tesla, but I'm sure others have a similar idea or issue, even though they've incorporated LiDAR earlier on. I'm on a soapbox here, but there needs to be sufficient communication to the user of what the vehicle sees and what it doesn't see in the immediate, right? So a lot of these cars will do a good job of presenting, okay, I know that there is a vehicle in front of me, and so I'm going to slow down, right?
Yeah.
But I don't know if it sees anything, 100 yards out, right?
Oh, yes.
And so at a certain point, it's going to either have to slam on its brakes, or I'm going to slam on my brakes, or we reach the point of no return.
Yeah, but so the issue is we can see very far, or the system, autonomous system, they have GPS and all that kind of information. But particularly, I would say, so right now, this is also an interesting area which is going on in self-driving in technical terms is how to incorporate GPS plus vision and LiDAR. I don't know, I'm not sure they are using LiDAR or not, but computer vision, there still need to improve for the deep learning algorithms because we don't have sufficient data for self-driving cars, first of all, right? So, and I just, in my previous semester, I present one kind of case study or presentation in my signal analysis classes, 2.5D voice basically. So what it is in the simple voice. So rather than just vision detection, why not vision plus audio? Because there is some car, it produces voice. So I want to know how far that car is in terms of voice, because in the night, if I cannot see the car, I can hear the voice of the car. So so people are also adding voice, vision plus GPS tracking. But still, this area is kind of growing. So this is a lot going on, and of course, there is always problem. Can I trust this system?
Yeah. Well, and I think you hit on a really interesting point. That is, humans are relying predominantly on our visual system for driving, right? But there are these other sensory modalities.
Yeah.
And I mean, it's the same reason that ambulances, fire trucks, police cars have sirens. Right? So even if we're not paying attention or not looking in the right area, we still hear them and react to them. But I think this kind of gets to a whole other issue, and I'd be really interested to hear your thoughts, kind of being on the deep learning side. It's not clear to me that we solve the problem of self-driving with deep learning, right? Because the amount of data that it takes to understand whatever's going on the back end makes it such that edge cases are essentially definitionally impossible to train on, right? They're just so rare that how do you do it, right?
So in deep learning, the main issue when training the model is when you train any deep learning neural network, very often with the data, it comes with a overtraining, or I would say what is the word?
Overfitting.
Overfitting. Yeah. Overfitting. So I overfit the entire model. So it works really good in the existing data, but it might be work bad with the future data. So that's the one big issue which I am concerned with when I train, even my research work, when I train my neural network. This is a big issue which I was always concerned about. And another thing is, I was in the past couple of months, I was thinking mimicking so main problem with deep learning is their structure and neuron structures, they are constant. Right, so I was thinking, why not apply the neuroplasticity? Because neuroplasticity, what it does is our brain, how I indulge into how our brain works. Because when we got new information, it make new neuron connections, right? Why not mimic same thing? I don't know. I didn't read much about that, but I didn't find any paper which deal with kind of dynamic deep learning model. Rather than a static model, training that model, why not make dynamic?
Yeah. So from a technical perspective, I'm unable to speak to the feasibility of that technically. But
but even this, dynamic model, the training of dynamic model, I don't know, they require constant new data to make this dynamic.
Yeah.
And we are not sure this dynamic model, what is the trustability for that model in the self-driving cars.
Yeah. Well, and I think you're hitting on a really important distinction here, that and that is the functional difference between the human brain and these current approaches, right?
Yes.
You didn't need to see 10,000 pair of glasses to know that something is a pair of glasses, right?
Yes.
You developed a rule-based understanding of what constitutes a pair of glasses.
Yeah.
And that makes it inherently easy to then, extrapolate that information to a variety of different domains. Right? One of the theories of why humans have developed such complex language is it's evolutionarily beneficial.
Beneficial,
that
yes.
I can experience something and I can tell you about it and you can recognize it.
Yeah.
Right? I can't tell a neural network, hey, this one time I had a three-legged deer that came out of nowhere and just hopped along the road. It may struggle, right? If the feature component of that other leg is something that matters to this neural network, right? And so you're exactly right that we also have this degree of neuroplasticity of neurons that fire together, wire together. We talk about all the time, use it or lose it. Most of the development there is a function of kind of this neuronal pairing, right? And so one of the reasons it's so important to learn languages or instruments or things like that at a younger age is because you have a lot of neurons in your brain and a lot of synapses, so the connections between the neurons, that you're essentially going to lose with age if you don't use them. Yes. And so, we're developing this network that we're still going to be using. Yeah. There are degrees of neuroplasticity in the sense that we can absolutely, neurogenesis of the generation of neurons and stuff like that. But your brain is also remarkably competent at reusing things that it otherwise doesn't need to use, right?
Yes.
And so you see this with people who have lost vision, right? So your primary visual cortex in the back of your brain, for those who have never had vision, that primary visual cortex, instead of just sitting there useless, sometimes gets reappropriated in the brain for other computations.
Yes.
And so
Stephen Hawking.
Yeah, exactly, right? And so, it seems to make sense that if what we're trying to do with an artificial neural network, right? We're trying to at least insinuate that it's based off of the neurons in our brain, right? It would make sense to have some sort of dynamic thing that you're talking about that can be reactive, but also understand the nuances such that it can forecast into the future like our own brain can.
Exactly, because when you make dynamic, so rather than just making software which run the autonomous car, which is static, why not make dynamics so that it's changed over the period of time, so that that model become you basically it's also interact with you, get the feeling what you are feeling, and also judging based on your feeling. So, for example, I am driving. So a couple of people has instinct to drive very fast. They are not afraid of fast driving. A couple of people are on a safe side. If there is a 40 miles per hour limit, I drive 35. A couple of people may go 40 or 42. So they're fast drivers. A couple of them are slow drivers. Autonomous car don't care about that. So making dynamic model, so each and every car, if they make this model, it also encounter human factors, and they see that this person when I drive slow. So it's kind of also adding human instincts and feelings into that model and making dynamic basically.
Oh, absolutely. Well, and so some of the manufacturers have essentially a way to quote unquote fat finger that in, right? So you can go into Tesla's menu, and I keep using Tesla just because that's who I'm most familiar with. But, where you can go in and say, I'm okay with you going 10 miles an hour over the speed limit, right? But there's not that kind of ongoing thing of, that's a very specific instance that could generate discomfort, but there's a much broader thing, right? People are going to have nuance in what constitutes comfort for the driving experience. Right? It could be following too close. It could be speed. It could be lane deviations. It could be the big rig that comes by you. So I think you're exactly right of having a system that learns, but I don't think necessarily learns in the typical computer science deep learning way, right? It has to have.
We need a whole I don't know I'm an aerospace engineer, so but deep learning, it's not only to we either we have to change neural networks with something else, or we have to like augment neural network with other kind of advanced system. Actually, reinforcement learning might be a good option, but still reinforcement learning has their own limitations. So and we I don't know, like computer science people, or maybe other people have to, like humans as a cognitive psychology experts and computer scientists, they have to work simultaneously, hand by hand, to overcome these issues, I would say.
And I think the thing that drives me particularly nuts, and I think a lot of other folks who are in this domain, Elon this summer tweeted out something about how the issue of solving self-driving was a lot harder than he anticipated. To which all the psychologists in the room say, no crap, right? The human brain is the most complex thing we've ever observed, and we don't really understand how it works. And you're saying that, just throw enough data at it and we'll figure out how to drive, right? They've done a good job in very specific cases.
But like over the human brain is
it's unbelievable, unbelievably complex of what our brain is actually able to do in that environment. Right?
Like each and every environment we interact differently. Like so your brain is whole different story than mine, right? Your neuron connections has different like growth rather than mine, right? So we act differently on different situation. Right? But self-driving car, not.
Well, and you see a lot of these cases wherein not only does it not interact differently, sometimes it doesn't even act appropriately in an obvious case. There was some picture that went around the other day of their, and I hate to keep picking on Tesla, but again, it's what I'm most familiar with, of the Tesla misinterpreting the moon as a stoplight, right?
What?
And somebody tweeted at Elon saying, look, the moon is not an edge case. This is an inherently predictable situation, right? So solve it. And so, I think that gets back to the trust of, you have these kind of expectations of what the system should be able to do, but when it mistakes the moon for a stoplight, why should I trust it now? I mean, this is not something that is so French they wouldn't have thought of it.
So still improvement is needed, I guess. More research has to be goes on in this domain before they come up with good product into market.
And I mean, there is so much of that human element that they need to consider of the human interactions, the trust, the reliance. And part of that, I think, comes to branding. Part of that, I think, is actual design. There are a lot of other companies that are having similar issues here. But, I think it's a neat time to be alive. But it's also at times a maddening time to be a human factors.
Because human factor is so much important, because it doesn't matter how much good product is. Until and unless, so for example, Apple has a brand, right? People trust it on them. Other Android products might have super awesome feature which you are not able to find in Apple, but still people trust on Apple. So it's a main selling point, because people trust on them. Right? And people over the period of time will provide something which no other brand can provide. Right? So it's the same as it doesn't matter how good your autonomous car or self-driving car is, people trust on them or not. It's a main issue. So that's where I think human factor play a very critical role, I would say.
Oh, absolutely. Well, and I think Apple's a great example of this, right? Because Steve Jobs was essentially the one to popularize personal computing. Right? Creating the graphical user interface for people to interact with made it so that now, you didn't have to learn some degree of inline commands to generate a Word document, right? It had an icon. You could click on the icon. And so, I think that, like you said, it's a great example wherein people develop this allegiance because of their trust or their expectations or just their affinity for it, right? That make it such that even though an Apple product may be inferior to an Android product, I'm not saying it is, but it may be, people who like Apple are going to stick with Apple, right? They just make it a really easy experience.
Because Apple main focus is make things simple.
Yes. Yeah. It is less of give the user the tools to do what they want and more of give the users what we know they want.
Yeah, because I see a lot of companies, mobile phone website, like they mention this feature we have, this much amount of megapixel camera, we have flip cameras, blah, blah, blah.
Yeah.
People don't care about that. People want simple thing which they can trust, they can do the daily usage. Apple perfectly fit for that.
Oh, yeah. Well, and I'm going to butcher this quote, but Steve Jobs once said something to the effect of people don't care about your product, they care about what your product can do for them.
Yes, right? Exactly.
And so, and I think that to some degree is going to dictate, as we go back to self-driving cars, the future of these self-driving cars, right? Because right now you're having a lot of early adopters.
Yes.
Even as it becomes more democratized, there are either financial barriers or technological barriers, right? So there's a company, Comma AI, run by George Hotz, that for about $1,000 can turn most modern vehicles into a self-driving car. Right? It's just a little plug-in insert and a camera on the dashboard. But there's still a degree of technical experience that's necessary. And so the people you're getting adopting a lot of these technologies now are those who are really interested in the technologies. But what does it look like when it's, the suburban soccer mom or the dad taking his kids to karate or whatnot, who have no knowledge or interest in learning about this stuff?
Yes.
But they just want a vehicle that's going to get them from point A to point B, right?
Yeah, exactly. So yeah, basically the bullet point is this system is capable enough to get me from point A to point B. That's what they care.
Yeah.
For safely, of course. Yeah.
Exactly. Yeah. Well, and it is that safety component. And this is where you start getting discrepancies between, I think, what's promised and what's realized of calling it full self-driving suggests to people that it is full self-driving, right?
Oh, yeah.
But it's not full self-driving, right? It is partially self-driving.
Yes.
It does a very good job in certain circumstances. But people have expectations and thus purchase this equipment thinking, okay, it will allow me to take a nap on the way to work, right? Or it'll allow me to read a book on my commute, right?
Yeah.
Or what have you. And so I think that's another area of real interest of, okay, people have expectations. What happens when those expectations are violated? And what does that do to kind of their long-term trust development, interactions with the system?
Yeah, because when one person trust broke, word of mouth spread very fast.
Absolutely.
Very
Absolutely.
fast.
Yeah.
And it affect on your sales of any company.
Yeah.
And the reputation of that product.
Absolutely. Well, and it's profoundly interesting to, this is not scientific by any means, but, going to Twitter and following any big news stories about a self-driving car accident or fatality or, any robotics company that's gone bottom up or things like that.
Yeah.
It is, okay, how much can we chart the contagion of that information? And once it gets hold in its host and its user, what influence is that going to have on their experience?
Yes, it's big domain.
Yes, yeah. When you kind of step back and look at the 30,000-foot view, it's a little daunting.
Oh, this still a lot of component here and there need to assemble to make full good system, I would say.
Yeah, absolutely. And I don't want it to come across as I in any way am kind of a neo-Luddite or anything that doesn't see the utility in this technology. I think this technology is awesome.
Yeah.
I just think that there needs to be greater, and this isn't just for self-driving, but I think there needs to be greater consideration of the human user beyond just let's just train it.
It's not going to work. It's not going to work like that at all. Yeah.
So it's
yeah. Well, let's talk about. We talk about Tesla.
Yeah.
See, it's very interesting to communicate with that. Now let's focus on specific age group people. So right now, early adopters, right? Mm-hmm. They mostly, as per my point of view, I might be wrong, but early adopters are between age of 20 to 30 or 35. because like they are more passionate about current advancement in the technology. They want to get new products every day. They encounter, basically they're more indulged into the consumerism, right? So like what's affect their brain in this autonomy? So what you think about this age group, if they grow maybe 50 years, like they, for example, from 20-year-old kid who is using self-driving car, right? When he come to 50, his age become 50, what's your thing, like what's his perception looks like? Because he encountered a lot of autonomous, not only self-driving car, he use Apple environment. And I'm not saying like phone, they create whole different environment, right? Apple environment, we have Siri, we have, basically we are like mimicking our entire brain into the external products. So they have, technically they knows what we like. Amazon, they know what we purchase. They know what type of sweater we like. What type of shoes we like, right? So this is like kind of, we are creating artificial ourselves by using these different products, right? Which is not possible before 20 years ago.
And it is incredible because that customizability seems to be what is fostering the growth of a lot of these companies. Right? So Google giving you results it thinks you want, not based off of the totality of everybody else, but the totality of people who are like you, makes it a far superior, in terms of finding what you want to find, search engine compared to like Bing, right, or DuckDuckGo, or things like that. I'm not saying that Bing doesn't try to do that, but I think Google's just figured out a very good way of going about it. But yeah, I mean, you're exactly right. I'm sure everybody says this, but this has to be the most exciting time to have been alive in history. Because we are literally, like, I don't know how old you are, but my generation, there was a time before everything was on Facebook or MySpace or anything like that. Right? So part of my life existed before really the popular internet existed. But kids now, I mean, even some of the younger students I have, that's not true, right? Every element of their life, from birth to the present day, is online, right? And we're now getting to the point of that touching essentially every element of your life, right? So you started off asking about, the 20-year-old to 50-year-old in terms of self-driving car. I don't know if we're there yet, but I suspect in the near future, if we're not already there will be a generation born for whom they will be able to experience the freedom of vehicles without ever having to learn to drive, right? And so having a truly, fully self-driving car, I think, is something that we're going to see this really interesting generational shift of kids who come of age, of where we typically learned when or how to drive, but don't have to learn that, right? Because the vehicle is going to drive itself. The interesting question will be, what does the phasing of that look like? Like, I love driving. I love the physicality of driving. I've got an automatic, but I preferred having the old manual cars. It was a full experience for me. And I'm sure there was a similar transition of people going from riding a horse to a Model T, right? And so I don't know what this looks like, because in some ways the difficulty of self-driving cars stems from the fact that not everybody's in a self-driving car, right? If all self-driving cars are rule-based, you can at least make a reasonable prediction of what they're going to be doing based off of known rules. But humans are at times irrational or flighty. We get distracted easily. Like that, right? And so it'll be interesting to see, once these 20-year-olds become 50-year-olds, to what degree do they have the choice to continue to drive, right? It may not be legislative, but it may be these insurance companies saying, all right, well, your insurance is now going to be $50,000 a year if you want to drive yourself, because it's just too risky. And so I think and this is tying back to that initial point of, I think as these generations come up, for whom there has never been a time where they weren't online in some capacity, whether it's parents, post-peers, or anything like that, they'll be a lot more comfortable with this transition to a vehicle knowing where it's going, where they're going at all times, right? Having some sort of information center of saying, you get in your car and it just looks at your schedule and takes you wherever you want to go. It's not clear to me that folks my age and older are going to be comfortable with that idea.
Yes.
I don't have data to support that. That's kind of my own expectations.
Yes.
I don't know. I mean, what do you think? Is your expectation that there is going to be an obvious cross-sectional difference in the willingness to rely on a fully self-driving car, not necessarily just because of trust, but because of all the privacy issues and stuff like that? Or do you think that it's something that with time, societally, we're all just going to kind of collectively accept?
I would say, so if I focus on the transition between the, or like from 20-year-old, so when self-driving car is already in existence, and if I were in 20 and go to 50, there is no difference much. But right now we are driving manual cars, right? But when self-driving cars come into the picture, it's kind of, so it depends actually. So this innovation of self-driving is like, we already in the verge of innovation. We encounter, so our brain is adopting lots of new technologies very fast pace. So it will be of course different from coming from horse cart to car. That transition must be different than from car to autonomous car. And it will be faster, that for sure, right? So if we overcome the trust issue, right, it will be exponential adaptation of the autonomous car, right? And one of my friend, he literally has his wallpaper in his mobile and laptop Tesla, and he want to buy Tesla at one point. He didn't have right now any sustainable income. He's a student. He's not, but he want to buy that because he's much. He even like when he see the Tesla, he oh my god, like that. his experience. Oh my god, oh this awesome. Yeah. So this are kind of early adopters. They want to, no matter what, they want to get Tesla. Because it's not like. Also, it's because they are not product oriented, but also they are Elon Musk fans.
Yes, absolutely. That's a big motivator, I think, for a lot of people.
Yeah, because like it's a brand.
Yeah.
Like the people, he's giving something, I'm gonna buy it.
Yes.
Yeah. So that mindset is changed very fast. So he is right now 20-year-old, right? And when he become a 50-year-old, he must be like, so when 30 years down the road, I don't think it will be dramatically changed for that particular person because he's already motivated to adapt to this technology. Because like this age group is, right now, they are more indulged in the Facebook, Instagram, TikTok, and all that kind of social media. What this social media creates is, it always gives you new information constantly. You always get your friend going for somewhere, which is not possible before internet. You are in your own narrow environment. You know the information in your city. Right now, you know what's going on in the world, what's going on in the other part of the world, right? So it's changed this age group, change the this external environment, change the adaptation power for that age group. So when they become 50-year-old, I don't know.
Yeah, and I mean it's tough because I don't know how it is culturally around the world, but the automobile in the U.S. has always kind of been seen as not only just a status symbol, but also an indicator of some degree of freedom, right?
Yes.
And I don't mean from government or anything like that, but individual freedom to go whenever, wherever, etc. Right?
Yes.
As a country, we're remarkably distributed population-wise, right? So you can drive a long way and still not get to another city. And that's not necessarily the case everywhere else.
Yes.
And so I don't know to what degree we're also going to see kind of cultural discrepancies there, where in those...
This will be not like particular line. It will be, of course, transition.
Yeah.
Yeah, it will be a spectrum. Yeah, rather than just one single line. Like for me, I came, so till now, I was in India. I came in January here, 2021. I drive geared cars there. I never drive, even I never see the like the autonomous car, automatic car. Yeah, we have gears 1, 2, 3, 4, 5.
Yeah.
And reverse. So we manually change different gears when we drive based on a speed. Right now I came here, I say, oh, I just have to like drive, park, that's it. And we have clutches in our cars.
Yeah.
Here we don't have clutches, just brake and accelerator. But this is kind of new automation, like small baby step, but it's different.
Yeah. Well, and I think that's an important distinction to make of the cars now, even though they don't have these self-driving, are highly automated.
Yes.
Right? Like, I'm not actually, I don't expect, but in most cars, I don't think I am doing anything with the pedals other than sending an electrical signal to the computer to control what needs to be controlled.
Yes.
Right? There's not that physical component in the same way that you get with the shifting.
With the shifting gears, yeah. So, yeah, it will be interesting to see what does the transition look like.
Yeah. I mean, I think it's an exciting time to be a part of it. I think that there are still a lot of unknowns about what the transition looks like.
Yeah.
You know, we keep hearing within a year we're going to have fully autonomous cars. We're not, right?
Yeah.
This is, I would, and I don't want to say it publicly, but I would, say in private, even though this is public now, that I would bet a large sum of money that even in the next 5 years, we're not going to have anything that really resembles fully autonomous cars, right? This may be a decades-long thing of that final refinement.
Yeah.
And the question gets to be, okay, at what point are, on average, they safe enough, or our perceptions of them are that they're safe enough for us to buy, without a steering wheel or something like that?
Yeah, it will be. So, and even like if we have autonomous car in the market, early adopters, which are 2% of the people, they buy it, but after it's a kind of a cavity from early adopters to sustain 64% in the bell curve.
Yeah.
When they adopt your product, which is autonomous car, self-driving car, it's a big challenge.
Yeah, absolutely.
It's really a big challenge because early adopters may buy, but the old people, they are afraid because they spend their entire life by using simple cars which you control by yourself.
Yeah.
And for them, it's super difficult to buy.
Yeah, well, and you also have to think about the financial elements of it. We're now rolling out vehicles that have some degree of self-driving capabilities, and suggestions are that, to get us to that full self-driving, it'll be a software update rather than a hardware update. Yeah. I don't know if that's true, but there is a large contingent of people for whom buying a new car is not feasible. Right? Yeah. And even buying a car that's only 5 years old is not feasible, right? And so we're looking at kind of this phase progression once we get past these early adopters. Buying a brand new car is great, but you're going to have folks that will not be able to buy a car that has this for decades to come, right?
Yes.
And so, I think that it presents a whole other issue of, outside of just the one-on-one interaction with the human in the system, kind of the societal interaction with a lot of these technologies.
Because used car has a really good market.
Yeah, exactly.
Yeah,
and I don't know to what degree these vehicles depreciate at the same rate that others do.
Yeah.
I mean, I know Elon has talked about his goal is for a Tesla to be an appreciating asset rather than a depreciating asset. We're not there. But I think it is an interesting idea, and then you start getting some of these other ideas of nobody actually owning a car, right? It's just kind of a fleet that drives around and picks you up when you need to be picked up and stuff like that. I don't see that being a wide-scale answer. I think a lot of people just like their vehicles.
Yeah.
But.
All right, let's talk about what is the effect on the brain or our perception or reaction when we interact with any autonomous system, like not only self-driving or any autonomous system? What is going on? So basically cognitive psychology.
Yeah.
So what goes on in that back box? Like, can you talk about like what's motivate us? Like, that surprising event, like, aha, when you call my friend, right? And it started, I'm calling this person, right?
Yes.
So what's going on in our human brain?
Yeah, so I think there's essentially three things we need to think about when we're thinking about human interactions with automation or autonomy. First is trust, that we've talked about a little bit, and I'll talk about that more in just a second. The second is workload, and so essentially what is it doing to your individual, the cognitive resources that you're putting in to whatever that task is. And third is situation awareness, right? And so what is using automation doing for your understanding of your surrounding environment? So as it relates to trust, one of the things that we need to consider is people come into an interaction with a system having differing levels of trust, right? It doesn't matter what the system is, there's always going to be this kind of discrepancy. And so the goal as a designer should be to get the users calibrated in their trust to the capabilities of that system, right? Because what I want to do from a safety perspective is not enhance trust. I don't want you over trusting the system such that you're now complacent, you're not paying attention to whatever it is.
Yeah.
But I also don't want you under trusting it, right? Yeah. There are systems you interact with daily that it makes sense to have exceptionally high trust, right?
Yeah.
You get into an elevator, you probably aren't thinking, oh God, I hope that the automated system here that's going to actually make it go up and down is going to work like it should, right? You're not thinking, okay, well, I wish there were elevator operators in here. But there are other systems that are not nearly as good, and we need to kind of calibrate people's expectations lower. And so part of that kind of cognitive interaction with the system is this consistent sort of reappraisal of how good is the system. And it's not always logical, right? Because certain types of errors are going to be more consequential than other types of errors, when the error occurs, how the error is responded to, things like that. But this kind of constant reappraisal is a really important element of that interaction. The workload aspect is also really interesting because it kind of depends on why you're automating something.
Yeah.
If you're automating something to then give somebody else, or to give somebody a secondary task, you may not have alleviated workload, and in reality, you may have put yourself in a really bad position because if that automated system fails, we have a fixed workload, and at a certain point we have what we just kind of colloquially call the red line of workload. That system failing now shoots your workload through the roof.
Oh,
right?
yes.
And so now you can't do either task well because the automated task needs to be done manually.
Yeah.
The secondary task needs to be done manually.
Yeah.
And so, that's kind of an extreme example of this, but there's still, people like to think of the sort of supervisory control as being a low workload task, but it's not necessarily, right?
Yeah.
You having to, and this pulls into situation awareness, you having to maintain a situational understanding of your environment is inherently taxing, right? You think about, and we'll go back to driving, but you think about all the contexts in which you are kind of doing a what-if calculation, whether consciously or not, while driving. Understanding that there's a motorcyclist in your blind spot is a really important thing to know, because if the car in front of you slams on their brakes, you don't want to just kill Joe Cyclist over there. And so there's this kind of constant meshing here of trust, of workload, of situation awareness that part of the hurdle is getting people aware of these issues. The other part of the process is understanding the inherent limitations of the human mind and thus trying to enhance this cognition. So some cars will have blind spot monitoring.
Yeah.
That is deliberately an attempt to enhance one's situation awareness.
Yes.
It can have consequential cascading effects of now people are becoming complacent and not actually checking their blind spot, and so it doesn't work. But yeah, it's this constant kind of appraisal of evaluating against what your goal is, where you want to get. How am I going to accomplish this goal successfully?
Yeah.
And I need to be consistently appraising whether or not I have the ability to actually do that. And you see this a lot with like people who like text and drive, talk on the phone and drive, stuff like that. 75% of people think they're better than average at driving, which it's mathematically impossible, right? But it's because people are not that good at taking into account these effects of situation awareness, of workload. Less so trust in this example, but in the actual driving process. And so, I'm biased, but it all comes down to the thoughts of the user, whether they're conscious thoughts or just kind of instinctual responses and things like that.
I see. Okay. So, I totally agree with that, because like when you so technically automation, what it does is it's reduce your workload. You're delegating some work to the machine, basically. When you automate something, you delegate something to the automatic system.
And it doesn't always have to be the delegation, right? The delegation implies some degree of like, we are automating a user's current task, but you can also have the automation of things that wouldn't be possible if it were not for the automation, right?
Yes.
And so, I think it's kind of a nuanced distinction, but I think it is still one worth noting, because that changes potentially the workload profile. Because now it's not just you're taking away work that the user has to do.
Yeah.
You're adding something in that the user cannot do.
Yeah. Yes.
Or you're adding something in where the user is now having to add something to their workload as a function of just having this new technology come in.
Yeah, it's the same like swarm robots. Like when I have one master robot, for example, let's say drones. I have master drone and I have other small drones, which this master drone, which I control by myself. But when I say, hey, perform this task, this master drone give the information for all the different drones. Okay, this is what I'm gonna do. So it kind of allocate based on their capability. This master drone knows where these different drones are, their current position. Based on that, he allocate different tasks to them. So this is very complicated task to do for user.
Oh yeah.
But when we program that for this master drone and we create this system, which is swarm robot, it can do like technically anything, any complicated task, for example, heavy lifting or making buildings. They are capable to transform bricks to one place to another place in a very fast manner.
And I think that's a really kind of important thing to be thinking about, and a great illustration of why consideration of the human is important. If I told you that you have to control 1,000 drones, there's not a chance, right? But if I tell you you have to control 1,000 drones that have some sort of governing central architecture, that becomes a more feasible task.
Task.
Right? So now you've augmented what the human can do as a function of having 1,000 drones, but you're not necessarily putting them in a task that's just impossible.
Yeah. So this is basically this is kind of making artificial structure, brain structure, which our brain control different brain structure, which is master drone, and it control all the systems. This very innovative thing.
It's exciting.
All right, so so let's talk about your published research paper and books. Like what type of publications you have done?
Yeah, so we've kind of touched a little bit on what I've done with like the Tesla and the most recent paper. But if you look at my CV, there is this clear kind of pivot point of focusing on the human visual system, right? So some of my early work was looking at what we call top-down influences on visual perception. So does, for example, my available level of energetic resources affect my perception of kind of distance or of slope, right? So is it literally changing what I'm seeing, right? So that's what I did in graduate school. And then I had an opportunity to intern at the Air Force Academy during my PhD. that's when I started focusing on the automation elements. And so my dissertation was looking at essentially the way in which the visual system is treating automation, right? Is automation a tool, or is it just kind of an indication of something happening out in the world? It's a gross oversimplification, but just looking at essentially what are the consequences of automation on our actual spatial perception. And so that was where I started really getting into more of the automation stuff. The work I did at the Air Force Academy was largely focused around this Tesla stuff. And then I've talked a little bit about some of the projects I've done here, but some of my collaborators here at UAH that I'm working with and I are kind of working on a couple of really interesting projects that are funded through different mechanisms, right? And so one is looking at acceptance and adoption of automated technologies. So this is funded by the Navy, and you can think about the context in which the Navy acquires some sort of automated technology, but you, Chris, don't want to accept that technology, right? You don't want to use that technology. You know how to do your job, whatever. Right? And so what we're looking at is different mechanisms by which we can get you to use that technology, right? Aside from me just saying, use it, right? What are the ways we can get you motivated to do so? So obviously we can have extrinsic rewards, right? So those are rewards, outside of you. So, I mean, that could be financial. We're not manipulating financial here, but also things like gamification. And so if I make it such that you get points for every time you do something that it's supposed to do, we know that people tend to use systems more because of that. Also looking at reputational or leadership, or leaderboard, such that, do you think that I'm going to put your name on a leaderboard with all of the people you know, such that there's now this kind of expectation that I have to be better than everybody else? And then even just like simple feedback of saying, good job. Right? So how's that affecting that? So, that's one of the projects I'm working on. It's Dr. Brian Mesmer, Christine Vager. I'm also working with Samson Golston and Vinitha Menon here, all at UAH. And we're working on a project funded through the Army. And this is a little bit more broad in the sense of human interactions with systems, right? And so this is where we're starting to get into some of the work about what's known as system-wide trust. So my trust in one specific component of a system can potentially have cascading effects, or so goes the literature. And we're writing a paper right now about why I think that there are some fatal flaws with the logic used in this. But so I won't preview those until I finish getting those thoughts together. But so looking at that, we're also inherently interested in developing these systems so that they have an understanding like you and I have, right? So one of the things we think about when we think about human-to-human teaming, human-to-human interaction, is that we have the ability to pick up on certain things, right? So if I said something right now that was incredibly offensive to you, I would see some sort of physical reaction, right? It may not be discussed, but it may be you now like kind of closing off, right? It may be some sort of indication. But similarly, if I do something that's boring you, or if I do something that's violating your trust, I'm getting that sort of feedback, right? So how do we develop these systems that have that sort of understanding? The absence of that understanding can be incredibly crippling, right? And so we have a whole spectrum of disorders, right? Autism spectrum disorders that are essentially the inability to pick up on these social cues. And so we're developing systems that have no ability to pick up on these social cues, which is already essentially putting a barrier in the human interaction with these systems. And so one of the things that I'm particularly interested in is how do we start modeling some of these cognitive constructs that we're fairly good at picking up on in one another for a system to be able to use moving forward, right? So it can say, I understand you as the user, as the operator, and as such, adapt when it needs to adapt, but also maintain this kind of naturalistic interaction such that I don't have to tell the system, it's screwed up, right? You can just say, I'm detecting some unease here. And so coming back to that. So yeah, I mean, kind of the Cliff Notes version I always tell people is, I'm really interested in any time a human interacts with automation, a robot, or artificial intelligence.
Oh, okay.
Right?
Yeah.
Now I realize those are incredibly broad categories, right? But it's, I'm really interested in the interaction of the human with these kind of cutting edge technologies.
Yeah.
So.
Yeah, because like always technology has to interact with human.
Yeah.
So yeah, it's kind of center point. Like to understand this is the main important part to adapt this technology. All the technology is surrounded by human, basically.
Exactly. Yeah. I mean, anytime the human's involved, a psychologist needs to be involved in the conversation.
Yeah.
I'm biased, but I think that's the irrefutable truth.
I also agree as an engineer, but yeah.
Good. We're doing our job here.
Oh boy, yeah. So that's pretty. Of course, like this is important stuff to discover. So let's talk about like human involved in this. So your cognitive psychology, what are the other aspects which are massively affected over the course of, let's say, 10 years or 20 years of cognitive science improvement, right? So what are the areas? So transportation, we talk about self-driving car, but what are others? Space exploration, education, entertainment, politics?
Yeah, I mean, so again, I am obviously biased, but I think you would be hard-pressed to find any domain that has not in some way been significantly impacted by cognitive psychology over the last couple decades, right?
Yeah.
So we think to transportation, right? The banning of texting while driving is an inherently cognitive thing, right?
Yes.
What most people don't realize is that it's also incredibly dangerous to even just be talking on the phone. And it's not because of occupation of your hands, it's a cognitive factor.
Yes. Brain is involved in that conversation rather than focusing on what's going on in the external environment.
Exactly.
Yes.
Yeah. And so that's an inherently cognitive thing, right? The application of cognitive psychology to domains of education, right? So what are the ways in which we can be presenting information that makes it easier for you to remember, but also access down the line, right? And so, going to this whole idea of mnemonics, right?
Yes.
Make things. So I teach the statistics class here, and I start off every semester by just reminding everybody PEMDAS, right? The order of operations.
Yes.
Even if people don't remember what PEMDAS stands for, most people remember PEMDAS.
PEMDAS, yeah.
Right? And so, obviously in the education there. In marketing, I mean, I think a big element of marketing now is to try and create these
recommendation systems.
Yeah, these associations that people don't necessarily know. It's the typical case of, you see a car and then you see a good-looking woman. This is kind of the classic oversimplified version, right? But they're trying to pair that sort of physiological arousal, and I don't mean sexual, but physiological arousal with seeing an attractive member of the opposite sex with that car, right? And you make these pairs enough, the hope is that, now, that is kind of more the behavioral side of what I just described there, less than the cognitive. But and then also getting to like behavioral economics. So Dan Kahneman won the Nobel Prize. I don't know how many years ago it was now, but I think over a decade. And his collaborator Amos Tversky passed before he was able to get the prize as well. But on this idea of the irrational user, right? So economics has traditionally been this view that you have a rational actor that you can model, right?
Yes.
You know that they're going to interact in their own best interest. But we now know that's not true. So, if I asked you to go ahead and just spin a wheel, like you have in the Wheel of Fortune or Price is Right, right, where it has all the values up to 100, which would be the dollar.
Yeah.
And then I asked you what percentage of African countries are in the UN. Those are two completely unrelated things, right?
Yes.
But what we find is that the number you spun on the Price is Right wheel impacts your estimation of what percentage of African countries are in the UN, right? It's completely unrelated.
Yeah.
There's no reason you should rely on that. But it's this, what we call this anchoring effect, wherein you have this expectation,
Yes.
and therefore you anchor it across that, right? And there are other effects like the availability heuristic, confirmation bias is a big thing that we talk about now in society. So I always like to tell my students an example of confirmation bias is when you go to Google and you type in the truth behind whatever, right?
Yeah.
So people look for information that supports their
belief, their beliefs, yes.
And so, we see this a lot being manifest in kind of the technology. But yeah, I mean, anytime there is a human involved, which is just about every domain of life, I think you would be hard pressed to point to that and say, this has not been some way influenced by cognitive psychology in the last couple decades.
Yeah, and so when the as per your point of view, what is the kind of golden period in the cognitive psychology history where the lot of researchers are booming and influence? So there must be any decade or something like that where a lot of people indulge in the cognitive psychology. So I think the good question is when it's cognitive psychologists diversify from the behavior psychology.
Yeah.
What was the time period looks like?
Man, I'm going to kick myself for not knowing this. My recollection was it was kind of late 50s, early 60s. But I would verify that before you give that a trivia. But as far as, and this is going to sound incredibly self-serving, but I think as far as the most important time in cognitive psychology, I think it's right now. And I think that's for a couple of reasons. One, there's kind of been this cross-domain understanding, not just in psychology, but in a lot of other fields, that the traditional statistical methods we're using, like null hypothesis, standard testing, p-values, stuff like that, are inherently flawed, right? And so we've been relying on flawed methodology or statistical methodology to derive understandings about the nature of human cognition. Which has rendered a fair number of effects kind of null once we actually apply new approaches to it, right? So Bayesian statistics or things like that. I think that's an important thing. I think the other reason that right now is perhaps the most important time in cognitive psychology history is because there is this enhancement of technology that allows us to study things in ways we've never studied it before.
Yes, fMRI, right?
Yeah,
yes, fMRI and
and even so, fMRI is really good at spatial localization. You have things like EEG, which are really good at temporal.
EEG, yes.
So I think those, right, the portability of that gets a little bit more into like the neuroscience element, but cognitive and neuroscience are typically kind of lumped into the same group. But you also get the ability to develop much more complex computational models of human cognition.
Yes.
You're able to collect a lot more data, a lot quicker, a lot easier, a lot cheaper, that allow for these understandings to be developed, right? So, I mean, I'm not a programmer, but I, in an afternoon can write a program in Python that, samples at 60 hertz. And so now I'm getting all sorts of nuanced behavior from the user of whatever we're looking at that just wasn't necessarily feasible 20 years ago, right, for your average psychologist. And you also get the kind of democratization of a lot of these advanced technologies. Right? So eye tracking has never been easier and cheaper to have high fidelity eye tracking.
Right? True.
EEG, we already talked about the neuroimaging things. Just the capabilities of current computers allow for much more complex experiments. You're also getting these technologies like self-driving cars, like drones, things like that, where now I'm not having the person just pretend that they're interacting with a self-driving car. I'm putting them in a self-driving car and seeing what are the consequences. So it's self-serving to say that now is the most important time. But I really do think that we're at a really exciting frontier that has put cognitive psychology in a position to enjoy prominence moving later into this century. Once we start understanding collectively, we as a society start understanding the importance of understanding human cognition.
I see.
Yeah.
Well, yeah, it's of course, like over the last 20 years, like the internet boom, and then after in the 2015 to 18, the AI kind of artificial intelligence boom, and like I think 2018 was a big time in AI when a lot of companies are indulging and getting like making the products which is more involved with humans, and at that point the cognitive psychology become a frontier in the, I think, all the psychology domain too, because like this is so vital element when this kind of psychology has to come into picture when the advancement of technology come into picture, so
Yes. Well, and I think it's given people a really healthy appreciation for just how unbelievably complex the human brain is.
yes,
Right?
yeah,
I mean, AlphaGo or Alpha Zero or whatever iteration they're on now, I don't even remember, is incredibly competent in an extremely narrow thing. Right? But what makes the humans incredible is that we can be incredibly competent at a lot of things.
yeah,
Right?
yeah,
And so the attempt to try and replicate the brain, I think, has given society a much greater appreciation for just what an unbelievable tool we all have just sitting up there, browsing TikTok or whatever the heck we do.
yeah. So let's talk about the. So we have advancement of technology. So what's your thought about ethics of AIs and the deepfake, which is getting much more popularity on the. I think I saw one of the professor at MIT. He representing he introducing his class by using deepfake as Obama is
Yes,
talking.
I've seen that.
Yeah. So this is new. So initially I thought, oh my God, Obama is representing the class, and then after at the end of the speech, it's kind of disclaimer that okay, this is this is a fake video by using artificial intelligence. So what do you think about ethics of AI? Because when I saw that video, I cannot believe, first of all.
Yeah.
But like I see lips of the president, the ex-president, but yeah, so introducing that, this was really surprising for me. One point of time, literally, because the voice and the lips, and it feels like it's real. So what do you think about the ethics of AI in the future?
Yeah, so that's actually another project I'm working on right now with a couple collaborators here that we're looking at essentially susceptibility to deepfakes. But that is secondary to the fact that I'm not a computer scientist.
Yes.
I am not somebody who has spent a considerable part of my life understanding the nuances of code, and yet I was able to generate these deepfakes that we're using for our research project, right? By using open source code, and God, I wish I could remember the name of the authors on the paper, but there is an approach that allows me to take a static image of Joe Biden and upload a video of myself.
Oh yeah.
Yeah. And create it as if Joe Biden is moving his head around and stuff like that, right?
Yeah.
And I was able to just download a synthetic, a voice changer for free on the App Store to make myself sound like Joe Biden. And so I created these deepfakes with this open source code that was already there, adding a few lines of my own, and creating deepfakes that aren't going to win any prizes, but are passingly good enough that makes it such that you don't need advanced capabilities to do this, right? And that's where I think the ethics get really interesting. Of the cat's out of the bag, right? Any hope we had about limiting these systems is just gone. And so now you see kind of this arms race of enhanced capabilities and people trying to still be able to detect those capabilities, right? And so insofar as I know, we're still at the point where every approach to the generation of deepfakes can still be detected through artifacts in the videos and stuff like that. But we're likely going to get to a point where that's not true. I don't know. I mean, there's no law that dictates that would be true, but it seems very plausible to me. And so we then get into the question of, like, what do we do as a society, right? Because the ethical question of deepfakes no longer exists.
Yes.
Right? Because we all know that they're going to be used for nefarious purposes if they haven't already been.
Yeah.
And so the question about whether that's ethical or not is one for philosophers to just discuss amongst themselves.
Yeah.
Because as society, it doesn't matter whether it's ethical or not. It matters that it's already here.
Yeah.
Right?
Yeah.
And there are still kind of, I think, peripheral conversations you can have about what is the role of, for example, the U.S. issuing these as deepfakes as an attempt to, sow distrust or stuff like that. But that question continues, I think, to other domains that haven't fully realized the same level of success that like deepfakes have. So.
Yeah.
The conversation about artificial general intelligence, right? You have people much smarter than I am, Sam Harris, you have Elon Musk, you have Ben Goertzel, all these folks that are talking about artificial general intelligence in different ways. But I don't think that we are at a point now of having gone over the cliff.
Yeah.
Right? So there will become a point where you can't put the cat back in the bag.
Yeah.
I don't think we're there, but I also don't think people know when we'll be there.
Oh yes, this is the main part. Like when will we there? It's a big question.
Yeah.
Then, like the issue is, are we there? When we should apply any, like if there is an ethical issue, so we need any ethical issue or any ethical policies or not? When we need that, what type of policies we need that? It's a big issue to ponder, I guess.
Yeah, well, and I think the really interesting part of this, so for the longest time I was kind of the camp of just give it a moral code and it doesn't pose kind of an existential risk. Yeah. And I'm not one of these fatalistic folks that say it's going to doom us as a society, but there are idiosyncrasies that I don't think we're necessarily talking about as a society, in the sense that any artificial general intelligence, for it to truly have, I think, general intelligence, it has to have the ability to reason, right?
Yes.
It doesn't have to be a fully logical system. We're not fully logical. We still have general intelligence, I would say. But it has to have the ability to reason. And so we can't just give it a moral code and say, you have to follow this. Because it's not inherently logical, any moral standing we have, right? And so I think, to give an example here, I think his first name was David, but there's this idea of the is-ought problem, or Hume's guillotine. And it's this idea that you cannot derive what ought to be done from an observation about what's true in the world. So, for example, I can't say it's cold outside, therefore you should wear a coat. It takes a logical leap to get there, because it presupposes that you don't want to be cold.
Yes.
Right? And so it is logical for me to say it's cold outside, therefore if you don't want to be cold, you should wear a coat.
You should, yeah.
But the problem is, once we start looking at the programming of ethics into an artificial intelligence system, you cannot give it a logical foundation for any ethical or moral position.
Yes.
Right?
Yeah.
Society, whether we want to acknowledge it or not, is essentially built on the foundations of essentially an illogical, agreed upon moral code. Right?
Yeah.
And I don't mean illogical as in it's not good. I mean illogical in the sense that you cannot reason to first principles that it is in fact better to not steal than to steal. Right?
Yeah. It seems like if I kill, for example, if I kill someone, I kill for revenge or I kill for my safety.
Yeah.
It's my perception.
Yeah.
Right? If I'm in threat, I kill. Like, for example, there is, dog is coming and planning to bite me very harsh.
Yeah.
Then I hurt him. It's kind of understandable. Right? But if I kill him for revenge, I kill the dog for revenge, that's not ethical.
Oh, yeah. Yeah. Well, and so, I think that kind of gets to an issue wherein we have gut instincts that something is ethical or not. I think most of that is cultural, because you do see cultural discrepancies in kind of, there's pretty universal agreement that, you shouldn't kill.
Yeah.
But as you point out, there are circumstances wherein we deem that acceptable, right? Self-defense.
Yeah, self-defense. So the point is like, which ethics is come first? Rather than like self-defense must be higher priority than killing someone. You know, like if I kill someone for self-defense, it's good. But for revenge, it's bad. So it's kind of like ranking of the ethics and prioritization based on the circumstances.
Yes, and that's certainly how we've attributed it. But getting back to Hume's guillotine, you cannot logically argue that it is wrong to murder, right?
Yeah.
We all agree, in part, I think, for selfish reasons, because we don't want to be murdered.
Yeah.
We won't murder. It's kind of like disagreement that I'm not going to murder, but you can't murder too, right? But getting back to the AI element, you can't program in a logical system. So you have to assume that this system will adhere to whatever kind of collective agreement we say is appropriate. And people always like to go to Asimov's 3 laws of robotics, right? Aside from the fact that Asimov, I don't think ever intended for that to be taken seriously, there are also inherent flaws just in that. And as we start diving deeper into it, it does raise the question of, okay, we want a logical system, but we can't help but logically see the merits in what we're saying, right? That is moral and immoral.
Yes.
And so, what does the system do? I don't know.
Yeah.
I don't think anybody knows. And so I'm not in any way advocating we stop AI research. And it is different than like nuclear developments in the sense that, to develop a nuclear weapon, it seems like you have to have substantial infrastructure. Right? There has to be some component. It's not clear that artificial general intelligence, or even just incredibly advanced narrow AI, is going to require that much infrastructure.
It's software.
Yeah, it's software, exactly. Now, I think a lot of the deep learning approaches now are incredibly computationally costly.
Yes.
But who's to say that a new approach to AI doesn't come out that just proves to be, I could run it on my 2015 MacBook.
Yes.
There's no law of nature that precludes that from being true.
Yes.
And so I don't know how we keep the nefarious from implementing it, but also from the well-intentioned, that it turns out that an AI system that is of such intelligence that it can reason through things just says, you know what, the best way to end human suffering is just to kill all the humans now, and there won't be any suffering in the future, right? And so I've maximized the return possible by just neutralizing humans now. But I mean, this is one of the things that I love to think about and hear others talk about who are much smarter than I am. But it's a real issue, and I think we would be fools not to be considering it pretty seriously when we're playing God of creating something that could potentially be the end of us as a species.
Yeah,
but,
who knows?
Yeah, who knows?
Yeah. So, that's and also like this is an ethical issue. Are also dealing with the. So of course, we shouldn't like grow because any threat or because like there are no any standard which we can define that this is good or this bad. So there is no point to like limit the technological advancement based on our fear. This because like a couple of my friends they even don't know what is artificial intelligence, and I said this is just a math. This is just a partial differential equations which they use and they call neural networks and they do some math and they give some output. There is no fear in that because like basically this is what we make. So we can control this.
Yes.
Of course, like what's number when you train, we don't know what number will pop up. Right? So we just name this artificial intelligence because they are kind of giving us smart results, basically. These are just smart results, which is hard for us to get.
Yes, and my understanding is largely deterministic, right?
Yes.
Same input are going to give us the same output.
Yeah, you can determine that. You can, as I talk, like you can make the system dynamic, but you can even make like you can control their systems. You can control the neural network. You can control how they behave. You know, so it's not like if we find that in the future maybe there is some ethical issue, we can control that, right? Because like each and every technology has problem in the past. We fixed that, and we still exist. We are living awesome lives. It's the best time to live.
Yeah, I agree, 100%.
So it's AI system has to be improved, and of course, in the ethical issues, there will be, of course, not there are no point where we cannot control things. So
I'm going to push back on that. I don't know if that's true. Right?
Huh.
So we don't know what human consciousness is. Right?
Yeah.
We don't, there are a lot of attempts to localize in the brain where consciousness is, and this gets back to the whole Cartesian dualism, and I think it ties back nicely to your start here, but of the mind and the brain, right? Is the mind distinct from the brain in there? And so because we don't know what human consciousness is, I don't know who among us can look at where we're at with AI and say, if we run this code, it becomes conscious, right? Because in reality, a lot of these more complex things, we can dig into it, but we don't really know what's going on in kind of these hidden layers, right?
Yeah.
It is inherently non-abstract to know that, okay, we have certain weights, we have certain biases,
Yes.
right? But that's essentially what the human brain at a very
Deeper level
reduced,
work.
yeah, right? It's a neuron. It fires or it doesn't, right?
Yeah.
It has certain neurotransmitters that it puts out. And so I don't know that we get to a point wherein we say, this is going to become conscious. And once it becomes conscious, I don't know if we have control over it anymore, right? The computational capabilities of this system far exceed our...
Because they can think.
Yeah. Yeah, I mean, so once we get to a system that can truly reason, it can truly
then
think,
it
becomes conscious, has its own self-motivation.
Yeah.
I don't know if we can actually ever get there. It's not clear that, again, from the laws of nature, that we could ever create a system that is conscious.
Conscious, yeah.
But, I think you're right that it's always funny to see people talk about AI, and it's like, that's a multiple regression, right? That's not artificial intelligence. You just ran basic statistical methods here.
Yes.
And so it does get to the question of, what is intelligence? How are we starting to think about intelligence? And it does get between the narrow and the general. But, I think it's something that keeps me up at night thinking about.
Yeah.
So it's fun.
And like a lot of companies like OpenAI and the Boston Dynamics, which is they are heavily working on this stuff, and because like they are creating. So I just get to know GPT-3, which is like vast trained neural networks for natural language processing, and actually it's a text converter, I would say. But of course, OpenAI is working on AI and robotic systems a very kind of advanced and smart manner. They have super awesome algorithm, which I think about to at least they have partial consciousness for that software, to automate some things. So we'll get there.
It's interesting.
It's
and whether or not GPT-3 has any conceptual understanding of what it's outputting, it is still an incredibly capable system.
Yeah, because and also I myself work in haptic feedback system. So we create you can literally wear hand model, and this hand the cameras detect your hand position. It goes to the virtual environment, and in virtual environment I have certain setup. My hand interact with that setup in virtual environment, and I am feeling in real life that I am touching something. So basically, if I change something in virtual environment, I can feel what's like. For example, in the virtual environment, there is fire. I can feel heat in my hand. You know, so if that's kind of like out of the box. But if I generate AI system which dictate the virtual world, because in the fact that I am wearing that equipment, it's kind of Ready Player One. If you watch the movie, yeah. So if I'm wearing that suit, hey, I'm gonna feel that. To feel the virtual environment, and virtual environment has control with AI. It's kind of closed loop haptic feedback, so I can experiencing whatever I want and whatever I desire based on the AI system. Because, for example, I want to feel the skiing. I tell, hey, I want to feel skiing at the mount, like any the mountain in Canada or maybe Michigan, I guess, right? So absolutely. I just wear a suit; it will feel me. It will give me that feeling.
Yeah, it's crazy. it really, I think it's an exciting frontier.
Yeah, and I like this big companies. Myself, I developed a hand which experience that feedback. I literally feel the force of the virtual environment. What is there? I feel in my hand. Yeah, so we are about that. Like, of course, AI stuff is not there yet. Yeah. But these companies are getting there.
It's exciting.
Yeah, this is a really interesting talk about this stuff. So now let address what you think, what your advice actually for a new undergraduate or graduate students who want to get involved in psychology or cognitive psychology and learn how we interact with the things and how we process and change, like how our understanding of human brain in terms of psychology change dramatically over the years. They want to learn these things, how they can indulge in this area.
So, I mean, it kind of depends on the level. If somebody is looking at graduate school, I think obviously the best place to go is looking at kind of the source documents of research articles and stuff like that. I think, obviously taking the classes, engaging with faculty members. I think one of the best ways to really get your feet wet in cognitive psychology is to be thinking critically about essentially the why question, right?
Yeah.
Why is it like this? Right? Maybe it's because of a purposeful design, right? Or maybe it's because nobody thought better, right?
Yeah.
Kind of deconstructing the elements of this into trying to understand the very foundation of the human experience, right? That is our thoughts.
Yeah.
I think for anybody who's really interested in cognitive psychology, kind of as just a broad level, reading a book like Thinking Fast and Slow by Dan Kahneman, I think I was talking about earlier, I think that is a great place to go. I think that there are, fortunately, a lot of popular press approaches or popular press offerings within the domain of psychology, right? And so not just necessarily cognitive psychology, like Jonathan Haidt, Steven Pinker, right? I already talked about Sam Harris. So there are a lot of great resources out there if you just kind of want to dip your feet into it. But as far as really getting into cognitive psychology, thinking about what classes they can take at college or in graduate school, and really, starting to take advantage of this new wave of user experience research, which is, it kind of boils down to applied cognitive psychology, right? It's getting down to the human and its element, and the benefit of it exploding as a career field is that there are a whole bunch of certificate programs, there are a whole bunch of online resources. I'm not saying that those are a substitute for actually getting in the classroom and interacting. But I think that there are a lot of really interesting real world examples that if you just start looking at, potential disasters, explanation for disasters, like you were
Yes.
talking about before, the Asiana flight that crashed in San Francisco years ago, or 3 Mile Island, right? There's an engineering component, but there's a human component.
Yes.
And starting to read about that human component, I think, is a foundation for cognitive psychology.
I see. So it's kind of induce Kahneman to get involved in the cognitive psychology.
Yeah.
Yeah.
Yeah, I mean, I think,
It become catalyst.
yeah, exactly.
So, yes, regarding. So, this is about like students. So, like, what challenges you have faced? So, getting classes and understanding this cognitive psychology is the one thing, but when you do research in cognitive psychology, it's a whole different challenge. So, what you suggest for current researcher who is involved in that? So, what is the mental process they have to, the structure of the mind,
Yeah.
they have to develop to, getting acceleration in that research. What's your suggestion?
Man, that is so tough. So I have substantial imposter syndrome. Like anytime I go into a room with other academics, why am I here? Don't tell them that I don't know what the heck I'm doing, right? And I think one of the reasons I have been as relatively prolific as I have been in publication is to try and combat that, inferiority or imposter syndrome. But I think it helps to really love what you're doing because you're then always thinking about it.
Yeah.
Right? Even when I'm not working, I'm still thinking about work, not in the context of this is what I have to do or stuff like that.
Yes.
But I'm thinking about the very foundational elements of my interaction with my truck when I'm driving, right?
Yeah.
Or I'm thinking about, what it means for GPT-3 to have its capabilities now and what that does for the interactions with the system and expectations of the system, right? So, it's kind of a cop-out answer, but I think once you become really super passionate about what it is you're researching, the questions don't necessarily come easier, but it becomes easier to put in the mental effort and resources to get there, right?
Yes.
And so, as far as when it actually comes to the research design, I think the best process is always just read.
Yeah.
I love the quote. I can't remember who it's attributed to, but actually Isaac Newton. It was, if I'm able to see further than others, it's because I stand on the shoulders of giants.
Yeah.
Right. And it's that idea of I'm not trying to revolutionize the field. I'm just trying to take what brilliant minds have already realized and take them a step further. Not to say I want to be incremental. Right? I want to make real meaningful contributions, and wherein that dictates that we reconceptualize something that we thought was axiomatically kind of agreed upon. I'm happy to do so, but I think focusing on research as a tool to understand the most complex thing we know, in this case the human mind, or whatever it is, in robotics, the creation of something that seemed sci-fi 5 years ago that you can now do. That passion, I think, should not be undersold. I think if you don't like what you're researching, why do it?
The quote Elon Musk always the quote I always admire is, over the future, it's very hard to distinguish sci-fi with the reality.
Yes. Yeah.
It's so difficult because before 100, 200 years, we are not even I cannot imagine from flying from India to here within maybe 1 or 2 days. It's impossible. Yeah, flying is people don't believe that. Even so, I would say sci-fi is what gonna be, but in the future something will pop up which even you cannot think right now.
Absolutely. Yeah. And I think that's the most exciting about what I do of engaging with this technology of, there's another Elon quote that actually I think I even saw on your webpage of, what was it? I could either watch it happen or be a part of it or something like that. Right? And so, being a very, very, very inconsequential and small spoke in kind of the developments of these technologies is incredibly exciting to me. Right? I want, long after I'm gone, there's still to have been a residual benefit for the work I've been doing.
Yes. It's kind of effect like domino effect, which because like when you pull up one domino, it will affect future researchers, or they pull up your work, and it's kind of further existence of the like extension of the work, basically. Yeah, because people don't want to invent a wheel.
Yeah, exactly.
Yeah, please don't invent a wheel. Yeah, first like take a wheel, make a car, sell it. Different people take that model, invent a new things, again make a new, sell it. Like it's kind of progressive. Yeah, and I would say as even a researcher, I also want to be one stepping stone in the big picture, in the long journey. You know, one stepping stone in my areas to advancing whole community. Yeah.
Well, and I think our obligation, collectively, our research scientific obligation, is to not reinvent the wheel just for the sake of reinventing the wheel, but at times to ask whether the wheel's even necessary, right?
Yes.
So building upon something is great, but sometimes it takes the courage to say, I'm not convinced this is the right path we should be going down, right?
Yes.
And to look at that new thing. For all the crap I give Elon, I think he has done a great job of pushing society in certain directions, right? Electric cars are now no longer seen as something that's just kind of, boring, very slow, right?
Yeah.
It's exciting. I think Elon is largely responsible for a lot of these companies moving towards self-driving cars.
Yes.
The SpaceX things we have there.
Yeah.
There are a lot of other great innovators.
I think Neuralink. What's your thought about? Yeah. What's your thought about Neuralink? Because it will basically you input the chip in your brain.
Yeah.
So your communication with the action environment with your brain becomes so much faster. The frequency transformation from your brain, because if I type something in my computer or say something, there is some frequency of communication. But when I put my chip on my brain, the bandwidth and the transformation of information becomes so much faster. So what's your thought about this type of advanced technologies?
So I think Neuralink is the classic Elon example of overpromise, underdeliver, but still make impressive contributions along the way, right? His, at times stated goal of this is going to become a way to essentially offload all these computations, right? Or, you can be looking at innovation throughout the cortex with this chip right in the wires. It does not strike me as anything feasible. That being said, I think what he is doing is brilliant in the sense that he is now making, because of commercial viability, this sort of intervention that allows for example, paralyzed individuals to regain function of certain muscles, right? If we can now start essentially bridging the connection that was severed as a function of whatever the precipitating event for the paralysis was.
Yeah.
I think once you pay enough attention to a lot of these tech companies, you start taking things with a grain of salt and seeing that what's exciting about these tech companies is not what they're promising, but what they're likely to accomplish along the way to failing to accomplish what they say their final goal is. And that's not to detract from the merits, right? I mean, I think that there are all sorts of forces acting on that. But I think that there is a lot of excitement with people dreaming big and accomplishing really incredible things along the way, even if it's not
what they promise.
Sci-fi, of I can just upload my consciousness to a computer. But I think it's exciting.
Yeah, it's definitely exciting as well.
So
let's talk about what you. Okay, as a psychologist, it might be a different question, but what do you do for fun apart from research?
So apart from doing everything, I'm really big into Brazilian Jiu Jitsu, and I've gotten into Muay Thai lately.
What is like exactly that?
Yeah, so Brazilian Jiu Jitsu it's like wrestling, except instead of trying to pin people, you try and choke them or put their joints in position that if they didn't give up, and we just signify that by tapping, you would break the joint, right? And so it's an inherently cerebral thing. You know, there are a lot of folks, and this is not to say that there's any necessary components of, you know, an educational background to get there, but there are a lot of folks with advanced degrees who do train Brazilian Jiu-Jitsu because it's a chess match. Like it's a physical, three-dimensional, you know, me versus you chess match of I have to know what you're doing and I'm going to have to try and respond. So I love that. I've recently gotten into Muay Thai. I stink at that. That's essentially just kickboxing.
Oh, okay.
But I really enjoy that. I enjoy things that allow me to kind of turn off the brain for a little while and react.
Yeah.
I'm big into fishing. I also love reading, so if you have any recommendations for books. I'm kind of a jack of all trades, master of none. I love getting my feet wet in a whole bunch of different things. I just started trying to learn how to play the violin.
Oh, really?
I'm awful. My dogs hate that I'm trying to learn how to play the violin. But I really like the process of learning something new, a new skill set or a new way of thinking.
New way of thinking, yeah.
So
what's your favorite book to read? What's your favorite book so far?
Oh, man.
The better question is what book you are reading right now?
Yeah, well, my favorite book of all time, I think, is 1984. I know that's kind of a cliche, but I think Orwell had some really great insights into the human condition that I think are noteworthy. The book I'm reading right now is actually one by Jake Tapper called Outpost. I think it was turned into a movie, but essentially about operations in Afghanistan early on in the war over there. But I'm a real big history buff. More modern history, and I don't want to say buff in the sense that I know what the hell I'm talking about, but buff in the sense that I just love accessing that information.
Curious about,
exactly.
Basically,
So, I think particularly, this is down a rabbit hole you don't care about, but I think particularly like the American Civil War, I'm just overwhelmingly interested in because it was a war, maybe more so than just about any other war in history, that focused on collective ideologies, right? This idea that it was worth going to war over self-governance, right?
Oh, yes.
Now, again, this is down a path, but I love kind of indulging in kind of any of these domains that have a real kind of psychological element to it.
So you always find what's the effect on the brain.
I mean, I'm fascinated by the brain, and so whether the readings are about the brain or not, it's always really interesting to me to kind of see the ties.
With the brain, yeah,
exactly.
Oh, that's fascinating.
Yeah, I think so.
Yeah. Well, about to saying that. We had really awesome talk about artificial intelligence.
This was awesome, man.
Yeah, and effect on the brain. Yeah. And getting to know your different hobbies and how you tie up your hobbies with the brain. That was remarkable.
Well, I really appreciate this. It's been a great conversation. It's cool what you're doing. I think there's a lot of potential, and I'm really excited to see just how big it gets.
I also have privilege to having you in my podcast. My podcast name is Many Things in Why, because why is the main important thing which we are doing anything, right?
Exactly.
So, thank you so much for joining this podcast.
Absolutely, man. Thank you. I appreciate it.
Yeah. Well.